final project for Calculus 171. Part 1 of Part 1 for the final project gives us the graph of I and S respectively. And for the graph of I, the peak of the graph is denoted by S sub t. And you can see the graph of I is a continuous function as it has no jumps or cusps. And that gives us that the derivative of this function will have small changes over time. Part 2, we can see that the peak of the graph is given because this is where the graph changes from increasing to decreasing. In part 3, we're given the equation that I prime of t is equal to ASI minus BI, which then turns into the quantity of AS minus B times I, which would equal A times I times the quantity of S times B over A. Therefore, S times B over A equals the threshold value, which is given by this entire graph, which gives us that S of t is equal to B over A. Now, when S is greater than S sub t, which is the same as saying S is greater than B over A, that function of I grows. However, when S is less than S sub t, I shrinks. Part 5 of Part 1 of the final project talks about herd immunity. For herd immunity, we either want S to grow smaller or larger, preferably smaller to cause the infectious and susceptible rate to both decrease. When S becomes smaller, A becomes a smaller value over B, a larger value, which causes overall S to decrease and also causes I to decrease through vaccinations and other sorts.
Okay, so in the first part of part number 2, we're trying to explain that the derivative of this is equal to 0. So we add a little derivative tick up here, separate it out throughout our things. Then we plug in our prime values of S and I into the equation. So this results in this line. Then we can start to cancel things out and eliminate things, starting off with A and A, then S and S, which is still equal to 0. We can then cancel out even more. So this results in this, but now we can cross off ASI, and negative BI with BI, resulting in 0 equals 0. Part 2 of this problem, given that the derivative of this is equal to 0, when the antiderivative is taken, the original function is given minus a constant c. Add this c to both sides, and the initial function it will be equal to c. Part 3. The value of I infinity for all values of S of 0 is 0. This is because the virus cannot last forever. Eventually, all within the infected group will have died or entered the recovery group. Finally is part 4. For any value of t as t approaches infinity, all values approach 0. This is true for both sides of the equation. So as you can see, these are the same, except for the zeros are replaced with infinity over here, which will result in
This is part 3. In part 3, we're given this equation here and asked to use it to find where x equals s sub infinity, which is essentially the same as finding the zeros of this. So they give us this equation and they ask us to find where s naught is equal to x, which essentially just you're trying to find the zeros of this. So the way we do that is through the use of Newton's method, which looks like this, right? And so what we do is when they give us an initial value where we think that the 0 might be, we plug that into this and then evaluate for this new value. And then we keep evaluating those until we find a point where the differences between these is less than 1, and at that point we can determine that we're about as close to the 0 as we can need to be. And so in part 2, it's essentially similar. We have this problem, and so we have these 3 values of S naught. So we plug these values into this, and then evaluate them at a point where we would guess. So we have the graphs of this given these values, and so we can guess where the x or where the 0 is based off of these, and then we just use the same exact method to try to find the real 0. In part 3, for part 3 of part 3, we are given that the derivative of s of t plus I of t plus r of t equals 0. In order to prove that, we can differentiate them individually, and we find that the derivative of each of these is this. And so you see that each of these values would just cancel, leaving us with 0. Down here, they're telling us that s of t plus I of t plus r of t is equal to n, and n is a number that represents the total amount of the entire population. And we're asked to use this to determine the amount of recovered based off of n. And so we can do that by just rearranging this. So you can see that r of t is equal to n minus s of t minus I of t.